Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your same module, that is the database design concepts, and the new chapter or the new part, that is the part number 5, that is the advanced topics on the database. So this part is basically how to use the or how to make the advanced part, or what are the advanced topics of the database management system. So this chapter or this part also contains 3 chapters, that is chapter number 24, 25 and the 26, and that covers a number of advanced topics that is available in the database management system, that is used in the database management system. So let's start with the chapter number 24, that is the chapter number 24, that is the advanced development application, or how to develop the advanced applications, or what is the, how to develop the advanced application development. So there are a number of tasks in application development. So when we develop the application, there are a number of tasks, there are a number of, we can say, the criteria, number of application that is available in the application development. As we saw in the earlier chapters, that is from 7 to 9, that is how to design and build an application, that is how to design and build an application, what are the various steps to design and build an application. Now this chapter is focused on the advanced topics of the or advanced application development, that is what are the various advanced topics of the development, that is how to design and build an application. One of the aspect of application design is a performance. One aspect out of the application, that is what are the various applications or what are the various performance criteria that one expects from the or out of the application. In fact, it is common to find that once an application has been built, it runs slower than the designer wanted. So once an application is built, so it is while it is executing, it runs slower than the what the requirement of the designers, or handles fewer transactions per second that they require. An application that takes an excessive amount of time to perform the required actions can cause user dissatisfaction. That is, the user is not satisfied with the with the application, because that is application is not giving the response in the time, and is to be completely unusable at the worst. Applications can be made to run significantly faster by performance tuning. So whenever we develop the applications, so they run the faster, or they operate as per the user requirement by performing the or by performance tuning, which consists of finding and eliminating the bottleneck. That is, what are the various, we can say, the errors or loopholes or the bottlenecks that is available in the development or designing of the applications, and what are the various method to eliminate these bottleneck, and adding the appropriate hardware such as the memory or the disk. So this is the provision that is done by the performance tuning to check the performance tuning first of all, and if there is any error, remove the error, and then provide the services, provide the database system with the proper tuning. And there are things that a database system administrator can do to speed up the processing for an application. And then benchmarks are standardized set of tasks that help to characterize the performance of the database system. So whatever the performance of the database system, whatever the performance of database system, they are divided, or they are categorized as the performance of the database systems. They are useful to get the rough idea of the hardware and the software requirements. So these are the benefits, or the benchmarks are the methods or the ideas, or what that is requirement, that is what type of hardware and the software requirements are used of an application even before the application is built. And applications must be tested as they are being developed. So whatever the application that is used, that is they are being developed, testing requires generation of the database states and test inputs, and verifying that the output matches the expected output. So whatever the expected output, whatever the scheme that is available in the generation of the database. We discussed the issues in application testing. That is, legacy systems are the application systems that are outdated and usually based on the older generation technology. So whatever the legacy system, that is outdated technology that is available, that is usually based on the older generation technology, and they are often used as a, or they are often at the core of the organization and run mission critical applications. And standards are very important, or standards that is developed, that are very important for the application development, because without using the standard, without using the rules and regulation, that is standard that is available, we can't develop the good application. So that is very mandatory, or that is very important for the application development, especially in the age of the internet, that is especially whenever any data will arrive from the internet. So standard is very important in case of the internet, since Applications needs to communicate with each other to perform the specified task, because application must be interacted with each other over the internet to perform the specified task. So there is a requirement of the standards also, so that the data will be available, or we can say the data is available over the internet, so that it is available and there is no, we can say, the duplicacy, there is no error, that is data is simply get the user, or simply user get the data by using the simplification. Next is performance tuning. So tuning the performance of a system involves adjusting various parameters and design choices to improve its performance for a specific application. Tuning means adjust according to the performance. So performance tuning is nothing but involving or adjusting the various parameters and the design choices. That is, what are the various design choices, what are the various parameters that is used to improve the performance for a specific application. That is how to improve them and how to make them important, or how to improve the performance for a specific application. That is a performance tuning. Various aspects of database design, database system design, that is ranging from high level aspects such as the schema and the transaction design to database parameters such as buffer sizes, and down to hardware issues such as the number of disks, also affect the performance of the application. So whenever we say about the tuning of the performance of the system, that means whatever the data, whatever the content that is used, that also involves the performance, that also involves the parameters and the various choices to improve the performance for a specific application. And each of these aspects can be, or aspect can be adjusted so that the performance is improved. So that is every aspect is taken into consideration, so that it will affect that data, it will make the data understandable, and it will improve the performance of the standard. Next is, first point of this topic is performance tuning is improved set orientation, or improving set orientation. So when SQL queries are executed from an application program, so whatever the SQL query that is used, that is executed from an application program, it is often the case that a query is executed frequently. So whenever SQL query is executed from the application program, it is often the case that a query is executed on a frequent basis. That is, they improve the performance, but with different values for a parameters. Each call has an overhead of the communication with the server. So that is every call, whenever we use, and every call that is used with the various delivery, that is used with the various provision that is available with the database management system in order to process the overhead at the server. For example, consider a program that steps through each department invoking a embedded SQL query to find the total salary of all the instructors in a department. That is, to find out, this is a query that is used to find out the total salary of all the instructors. That is, whatever the instructor that is used to get the total salary that is available in the department. So this is a query that is used, that is a select sum salary from the instructor, that is the table name in instructor where the department name is given. So whatever the department name, whatever the query that is given, that is available, that gives the total salary of all the instructors. Then instead we can also use a single SQL query to find total salary expense of each department. That is a select department name, some salary from the table instructor, that is grouped by the department name. So on the basis of the department name, they are grouped together, and they provide the department name as well as the salary of the employees from the table or from the relation instructor, that is grouped by the department name. This query can be evaluated with a single scan of the instructor relation, avoiding random input-output for each department. That is, whatever the department, whatever the relation that is used with the single scan of the instructor relation. And the JDBC API, that is Application Programming Interface, also provides a feature that is known as the batch update, that allows a number of inserts to be performed using a single communication with the database. So whatever the communication, whatever the update that is available, that will be used, that will be allowed number of insert to be performed using a single communication with the database. Figure 24.1 illustrates the use of this feature, and whatever the code that is available, that is shown in the figure, that requires only one round of communication with the database. Now this is one of the example, that is a prepared statement. PSTMT, that is the cone prepare statement, that is inserted in the once, and it is eventually growing in the sub queries. Another aspect of improving the set orientation lies in rewriting the queries with nested subqueries. So whatever the subquery that is available, that will be nested in the query, that will be lies in the rewriting the query with the nested subqueries. That is another aspect for improving the set orientation. In the past, optimizers on many database systems were not particularly good. So whatever the optimizers, whatever the data that is available, they are not good, so that any query, or so that a query written, or the query can be written or written would have a big influence on how it is was executed, and therefore on the performance. That is, whatever the performance, what is the performance of the database system, that is how to use them, and how they affect the performance of the database system. Today's advanced optimizers can transform even badly written queries and execute them in efficient way. So whatever the execution way, whatever the effective way that will be used, to tune the individual query, that is less important than it is used to be. However, complex query containing nested subqueries are not optimized very well by many optimizers, and we saw many data that is available for the database management system. Next is tuning or tuning of the bulk loads and the update. That is how to tune whenever there will be a bulk load, whenever there is large amount of data, and the updates are also high amount. That is, there are so many updates are available in the database management system. So when loading a large amount of data or large volume of data into a database, such as the bulk load operation, performance is usually very poor if the inserts are carried out in a separate SQL insert statement. So whatever the insert statement, whatever the data that will be available, that will be available in the insert statement whenever a SQL insert statement is inserted. One reason is the overhead of the parsing each SQL query. A simple or more reason that performing the integrity constraint and the check that is available database management system. And to support the bulk load operations, most database system provides a bulk import utility and corresponding bulk export utility. That is, we can import the data in a bulk from other countries, and we can also export, that is send out the data in a bulk, that is a bulk export utility. This is the example, that is update department set budget equals to budget plus, this is the example where exists, that is another SQL query that will be available in this. The next is the location of the benchmarks or location of the bottlenecks. Next is the location of the bottleneck, that is how to locate the errors, or we can say the loopholes, where is the loopholes, where is the bottleneck that is available in the database, or that is available in the, we can say, the application that is designed, designed for the by using the rapid application, by using the advanced technology, and where are the bottleneck that is available in this one. That is the location of bottleneck. So the performance of most systems, that is at least before they are tuned, is usually limited primarily by the performance of one or more component known as the bottleneck. That is, the performance of more the system, or mostly system, that is usually limited by the performance of one or more component that is available, that is known as the bottleneck. For example, a program may spend 80% of its time in a small loop deep in the code, and the remaining 20% of the time on the rest of the code. So the program spend 80% of the time that is available in the small loop that is deep in the code, and the remaining 20% of the time on the rest of the code. So 80% is available in the small loop deep in the code, and the remaining 20% is available, or that is available for the rest of the code. So the mostly we can say the most focus is on the deep loop, or the small loop deep, that is available in the code, and the remaining 20% that is available on the rest of the code. Improving the performance of the component that is not a bottleneck does little to improve the overall performance of the system, that also improves the rest of the code. This is one of the example that is used, that is the queries in the database systems. Then however, when tuning a system, that is also used. So whenever a simple program are executed, the time spent in each region of the code determine the overall execution time. So whatever the time that is available, in the each region of the code, that determines the overall execution time. However, database systems are much more complex and can be modeled as a querying system. So whatever the database system that is used, that is used for the querying the system, that is used for the database management system, that is available in the database management system, that is a querying system. A transaction requests various services from the database system, starting from entry into the server process, disk read during the process or execution, CPU cycles, and logs for the concurrency control. and each of these services has a query associated with it, and the small transactions may spend most of their time in the queue. So whatever the queue, whatever the data that is available in the database management system, that is used for the database management activity. So this is one of the example, that is how to maintain the, or what are the various queries that is available in the database system. So this is the concurrency control manager. This is the icon that is used. There will be a log request, there will be a log grant that is used. There will be transaction manager, transaction monitor, transaction source. So first of all, there is a transaction source, that is from where the transaction will arrive. Then there will be transaction monitor, then the transaction manager, and the CPU manager. CPU manages each and everything that is available, or that is work with the transaction manager. There is a transaction monitor and the transaction source. As a result of the numerous queues in the database, bottleneck in the database system typically shows up in the form of the long queues for a particular service, or eventually or equivalently in the high utilization for a particular service. And if a resource such as a disk has a low utilization, then when a request is made, that the resources is likely to be idle. So whatever the resources, whatever the data that is used, that is a request is made, that is the resource is likely to be idle, in which the case is, the waiting time for the request will be 0. So whatever the waiting time that is required, that the waiting time for the request will be the 0. Assuming uniformly randomly distributed arrival, the length of the queue go up exponentially with utilization. So whatever the utilization, whatever the querying theory that is used, that is available with the database management system. Then the next is tunable parameter. That is, what are the various tunable parameter, how to use the tunable parameter, and what are the various modes for the tunable parameter. So database administrator can tune a database system at 3 levels. There are 3 levels that is used with the database systems. First one that is used, so the lowest level is the hardware level. So the first level, or we can say the lowest level that is available, is the hardware level, and there are multiple options that is used for the tuning system at this level, include the adding the disk or using a rate system. So this is another level that is used, that is how to add the we can say the disk, or how to use the or rate system. If disk input output is a bottleneck, adding more memory with the disk buffer size is a bottleneck. So this is a requirement, that is, if the bottleneck or if the disk buffer is a bottleneck, then move to the faster process if the CPU use is a bottleneck. And the second level that consists of the database system parameters such as the buffer size and the checkpoint parameter, that is also used. Then the finding the bottleneck, that is a tunable parameter, that is how to tune the parameter or how to adjust the parameter. The second level consists of the database system parameter. That is the second level, that is the database system parameter, that is for example the buffer size and the checkpointing interval. The third level is the highest level, that is the highest level. It includes the schema and the transactions. So first level or the lowest level is the hardware level. Second level is the database system parameters such as the buffer size and the checkpointing interval. Third level is the highest level, that includes the schema and the transaction. The administrator can tune the design of the schema, the indices that are created, and the transactions that are executed to improve the performance. And the 3 levels of tuning interact with one another. We must consider them together while tuning or when tuning a system. So all the 3 levels are combined together whenever we want to tune a system, whenever we want to involve with the system. The tuning of the hardware, that is how to tune the hardware or how to adjust the hardware, how to make the hardware very effective. So even in a well-designed transaction processing system, each transaction usually has to do at least a few input-output operations. So whatever the input-output operation that is used, so every transaction usually has to do at least a few input-output operations if the data required by the transaction are on the disk. So whatever the data that is required, that is available on that disk. An important factor in tuning a transaction processing is to make sure that the disk subsystem can handle the rate at which input-output operations are required. So whatever the input-output operation, whatever the database that is used, that is available for the database management system, that can handle the rate at which the input-output operations are required. For example, consider a disk that supports can access time of about 10 milliseconds and average transfer rate of 25 to 100 megabytes per second. That is used to destroy the, we can say, that is used to support a liter and 100 random access input-output operations. Notice here that the limiting factor is not the capacity of the disk but the speed at which the random data can be accessed. And the question is, for a given amount of money available for spending on the disk or the memory, what is the best way to spend the money or to achieve the maximum number of transactions per second? That is, what is the maximum amount, what is the maximum number of, we can say, what is the maximum amount of money that to be sent to achieve the maximum number of transactions per second, so that there will be a more number of transactions and the money is also spent at the less quantity. A reduction of the input output per second waves are as follows. That is the price per disk drive, and that is divided by the access per disk drive. Therefore, if a particular page is accessed n times per second, the saving due to the keeping it memory is n times the above value. That is the price per megabyte of memory is divided by price per megabyte of memory, or sorry, pages per megabyte of memory. So price is divided by the pages. Therefore, the break-even point is that n into price per disk drive divided by access per second per drive, that is the price per megabyte of memory, and the pages per megabyte of memory. And we can rearrange the equation and substitute the current value for each of the above parameters to get a value for n. If the page is accessed more frequently than this, it is worth buying enough memory to store it. Current disk technology and the memory disk prices are also used for involving the database management systems. This reasoning is captured by the rule of the thumb that was originally known as the 5-minute rule. And if the page is used more frequently than once in 5 minutes, it should be cached in the memory. That is, it should be cached up in the memory. In other words, in some years, they suggest during the enough memory to cache it with the database management system. Then next is tuning of the schema. So these are the various performance tuning that is available. That is how to improve the performance by tuning the various hardware component. By tuning the various components, we can say that deals with the database management system. That is the tuning of the schema. The next part is tuning of the schema, that is also used, that is also available for the tuning of the various schemas. So within the constraint of the chosen normal form, it is possible to partition relations vertically. For example, consider the course relation with the schema. So the course relation that is used, that is a course that has various fields. We can say the various attribute that is given, that is the course ID, title, department name, credit. So these are the 4 fields that is available with the course relation course table. For which course ID is a key, that is a primary key that is used, that is the course ID. And within the constraints of the normal form, BCNF and the third normal form, we can partition the course relation into 2 relations. So there are 2 types of relation that is used. One is the course credit, then the course ID and the credits, then course title department, that is the course ID, title and the department name. And the 2 representations are logically equivalent since course ID is a key, but they have different performance characteristics. On the other hand, if most of the access to course information require both the department name and the credits, that is using the course relation, it will be preferable since the cost of the join of the relation will be made available to the database management system. And the column store approach to storing data is based on the vertical partitioning, but takes it to the limit by storing each attribute for the relation in a separate file. And another trick that is used to improve the performance, that is used to store a denormalized relation such as join of the instructor and the department. This is another relation, this is another type by which the relation can be created, by which the relation can be stored. If such a query is executed frequently and has to be performed as efficiently as possible, the denormalized relation could be very beneficial relation. And materialized view can provide the benefit that denormalized relations provide at the cost of some extra storage that is available in the performance tuning of the materialized view. Another approach that is used to speed up the computation of the join without materializing it is to use cluster the records that would match in the join on the same disk page. Then next is the tuning of the indices, that is how to tune on the indices, that is how to tune in the indices level. So we can tune the indices in a database system to improve the performance. So whatever the indices that is available, that is used in the database system to improve the performance. If queries are the bottlenecks, that is if the query that is given are the bottleneck, we can spend we can often speed them by creating the appropriate indices on the relation. So whatever the relation, whatever the database that is used to get the relation, that is used to get the speed up by creating the appropriate indices on the relation. And if updates are the bottleneck, so whatever the update that is available that are the bottleneck, there may be too many indices that is available which have to be uploaded or which have to be updated when the relations are updated. So whenever the relations are updated, that must be available, that must be updated on the relation table that is used with the database management system. Removing indices may speed up certain updates. So whenever there will be update that is available, so whenever we remove the indices, that may speed up the certain updates. Then the choice of the type of index also is very important. So whatever the choice that is used, that is also very important in the turning of the tuning of the indices. Next criteria for performance tuning is the materialized view. So use the materialized view always, so that it will be used in the case of the two types of view that is used, that is the deferred view and the immediate view maintenance. That should be used with a care. However, since there is no not only space overhead for storing them, but also most important, there is also a time overhead for maintaining the materialized view. And a database administrator is responsible for the selection of materialized view for view maintenance policy. So it is the responsibility of database admin that is used for the selection of the materialized view and for view maintenance policies. A database administrator can make the selection manually by examining the type of the relations, or by examining the type of the query in the workload, and finding out what type of query need to be run faster and what are the various updates that needs to be executed more slowly. So that is a database administrator that is used to examine the various types of query that is available in the workload and finding out the workload and finding out the database management system. Then next is automated tuning of the physical design. That is one another criteria is automatic tuning is also available of the physical design. So most commercial database systems provide tools to help the database admin with the index and the materialized view selection. That is also used to provide the or to help the database system, so the administrator, with the index and the materialized view selection and the other tasks that is related to the physical database design, such as how to partition the data in the parallel database scheme. So whatever the database scheme that is available, that is used to materialize the view, that is also used to partition the data in the parallel database system. These tools examine the workload, that is the history of the queries and the updates, and suggest indices in the view to be materialized. The database administrator may specify the importance of speeding up different queries. So whatever the database admin that will be used, that is used to specify the importance of the speeding of the memory or different queries, which the tools take into account when selecting views to materialize. So whatever the materialized view, whatever the data that is used to materialize the various queries that is used in the database system. Therefore, some tuning tools also allow the database admin to specify the information about the expected size of the database and the related statistics. Then tuning of the concurrent transaction. So whatever the or whenever there will be a concurrent transaction, that is more than one transactions are executed at the same time, the concurrent execution of different types of transaction can lead to the or can sometimes lead to the poor performance because of the contention on the logs. So we first consider the case of read-write contention, which is more common, and then consider the case of read-write contention. So first of all, in case of the concurrent transaction, first of all the read-write contention is maintained. So first of all, read the data, then write the contention or write the data. Then the another approach is write-write contention. That is another approach. Several database systems, that is Oracle, PostgreSQL, and the Microsoft SQL Server, for example, supports a snapshot isolation, whereby the queries are executed on a snapshot of the data. And in SQL Server, executing the statement that is also used with the database management system, that is a set transaction isolation level snapshot. At the beginning of the transaction, that results in the snapshot of the database admin. And one way to improve the concurrency is to release the lock on the sequence encounter or sequence counter immediately after it is read and incremented. So whenever there will be requirements, so it will be read and the incremented. So that is the only way to improve the concurrency, that is used to release the lock on the sequence counter immediately after it is read and incremented. That is one way to improve the concurrency. And most of the database system provides a special construct for creating a sequence counter that implement early non-two-phase lock release coupled with special care treatment of the undo logging so that the updates will be available are not rolled back if the transaction aborts. Then this is a standard SQL that is a sequence counter that is used. That is how to create a sequence. That is a create sequence then counter one. In the above command, counter one is the name of the sequence that is used, and the multiple sequence can also be created with the different names. And the syntax that is maintained in the database system that will be used in the database management for the sequence that is not standardized. Then next is the performance simulation. That is the next part. So to test the performance of a database system even before it is installed, we can create a performance simulation model of the database system. So to whenever there will be a test of the performance, or whenever there will be a test on the performance of database system that is installed, we can create a performance simulation model that is used with the database systems. Each service can be used, such as the CPU or the disk, that is used with the buffer and the concurrency control that is modeled in the simulation. And the service time is also available that is used to capture or that is used to take the expect of the various resources. And since requests for a service generally have to wait for their turn, each service has an associated queue in the simulation model. Now next is the performance benchmark. That is the next topic, that is the performance benchmark. So we are finished with the performance tuning. Now next is performance benchmarks. Our next topic is the performance bottlenecks. That is, what are the various performance bottlenecks? We can say that what are the various hindrance that is available in the performance that is known as the performance bottleneck. As database servers become more standardized, the differentiating factors among the product of different vendors is those product performance. So whatever the product that is available from different departments, we can say different vendors, that is differentiated by way of their performance, that is differentiated by way of their product's performance. And the performance watermark or benchmark are the suite of tasks that are used to quantify the performance, that is used to identify the performance of the software system. So these are the performance bottlenecks are the number of tasks that is available that are used to quantify the performance of the software system. That is, what is the performance of the software system, what type of softwares are available, performances are available or provided by the software system. First is the suite of tasks. That is, what are the various tasks that is available in the software system, that is available in the database system to perform the various tasks. So since most software systems such as databases are complex, so since most of the databases that are used is a complex, so there is a good deal of variation in their implementation by different vendors, because most of the applications, most of the data that is very we can say that is the secure data. So we can choose the application, we can choose the various tasks that is available, we can choose the various applications, we can choose various vendors that is used. As a result, there is a significant amount of variation in their performance on different tasks, because there are different tasks, there are different variation in their tasks that is used in the bottleneck, that is used in the performance bottleneck. One system may be more efficient on a particular task. For example, if one faculty is available, or there are 4 faculties available, one faculty is available for the database, one faculty is available for the management, one faculty is available for the programming. So there are multiple faculties that are specialized in their work. In the same way, there are multiple systems that are specialized in their particular task. And combining the performance, oh sorry, hence a single task is usually insufficient to quantify the performance of the system. So a single task is not alone or is insufficient to quantify the performance of the system. That is, quantify means identify the performance of the system, a single task. Instead, the performance of a system is measured by a suite of standardized tasks. So instead, the performance can be measured by a suite of standardized tasks, that is multiple tasks is available, that is a standard task is available, that is known as the performance benchmark. So calculating the performance benchmark, calculating the performance by multiple system, that is known as the performance benchmark. Combining the performance number from multiple tasks must be done with the care. Suppose that we have two tasks, that is a T1 and a T2, and that we measure the throughput of a system as the number of the transaction of each type that runs in a given amount of time, say 1 second. And the system A runs T1 at the 99 transaction per second, T1 at the 1 transaction per second. Similarly, let system B runs both T1 and T2 at the 50 transaction per second. So suppose this is a workload that has an equal mixture of the two type of transactions. This example shows that a simple measure of the performance is misleading if there is more than one type of transaction that is available. The right way to average out the numbers is to take the time to completion for the workload rather than the average throughput for each transaction type. So there is a number, or that is the average number that is used to take, and that is used for the time to completion for the workload rather than the average throughput for each transaction type. And this is the correct way to use the harmonic mean of the throughput, that is calculating the harmonic mean of all the transactions that is used. This is the formula for the harmonic mean, that is n, that is divided by the harmonic mean, that is divided by the various transaction of their reciprocal, that is 1 by t1, 1 by t2 till 1 by tn. And the next is the database application classes. The next performance bottleneck, or we can say the next criteria for the performance bottleneck, is the database application classes. So there are multiple database application classes that is available in the database management system. So online transaction processing, that is the OLTP, and the decision support including OLAP. So whenever we are doing the transaction processing online, that is the OLTP, and there is a decision support system, that is a DSS. So that also includes the OLAP, that is the online analytical processing. That are the two broad categories of the application that is handled by the database system. These two classes of tasks have a different requirements. So there are different requirements of these tasks. There are different criteria of these tasks. High currency and the clever techniques to speed up commit processing are required for supporting a high rate of update transaction. So these are the two classes that will be used. These are the two tasks that will be used for the higher requirement of the commit properties. On the other hand, good query evaluation algorithm and the query optimization are required for the decision support. The architecture of some database system have to be tuned into the transaction processing that of others, such as the Teradata series or the Parallel database system, that is to be turned to the decision support. Other vendors try to strike a balance between the two tasks. Application usually have a mixture of the transaction processing and the decision support requirements. Hence, with the which database system is best for an application depends on the requirement of the mixture. That is, what type of mixture is needed for the database requirement. And suppose that we have a throughput number for the two classes of the application separately, and the application at hand has a mix of the transaction in the two classes that is available in the two classes of the application. And we must be careful even about taking the harmonic mean of our throughput numbers because of the interference between the transaction. For example, a long-running decision support transaction may accurate or may acquire a number of logs that is available that interfere the multiple transaction that interfere the transaction of the database management system. Now next is a TPC benchmark, that is a Transaction Processing Performance Council. That is a TPC benchmark, that is the Transaction Performance or Processing Performance Council, that defines a series of benchmark standards for the database systems. The TPC benchmarks are defined in a great deal. So these are defined in a great deal, or these are available in the great deal. They define the set of the relations and the size of the tuple. So whatever the size, whatever the, we can say, the criteria that will be used, that will be depend on the size of the tuples. They define the number of tuples in the relation not as a fixed size but as a number of the client transaction per second to reflect the area, or to reflect the large number of transactions that is executed in a correlated with a large number of accounts. That is a TPC benchmark, that is a Transaction Processing Performance Council. And there is also a TPS, that is a transaction per second. And the first service that is available, that is also available in terms of the price per TPS. And the TPC-A benchmark, that is also available in the database management system. The TPC A, B, C, these are the three benchmarks that were designed to model various benchmarking. And this is again TPC D benchmark, that is also used. Next, TPC H benchmark, that is used, or H used for the ad hoc. Then throughput test level, then composite query per hour traffic. Then TPC W web commerce benchmark, that is the end-to-end benchmark that model website having a static content primarily and the dynamic content generated from a database. Now, next is the other issues in the application development. That is one, performance tuning is over, performance benchmarking is over. Now, what are the various other issues that is available in the application development? That is the other issues in the application development. So in this section we discuss two issues in application development, like testing of the application and the migration of the application. And these are the various critical issues that is available in the application development. That is how to test the application and how to first of all how to what's the criteria for testing the application, and how to migrate the application, means how to migrate the application, or we can say how to transfer the application from one part to the another part. That is the migration of applications. So first is the testing the application, that is involves designing a test suite, that is a collection of test cases, that is how to test the application, what is the criteria to test the application. So testing is not a one-time process, since programs evolve continuously and bugs may appear as an unintended consequence of a change in the program. Such a bug is referred to as the program regression. So whenever we test something, whenever we do something, so that testing involves designing a test suite, that is a collection of the test cases. And testing is not a one-time process, since the program are involved on a continuous basis and the bugs may appear in an unintended consequence of a change in the program. Such a bug is referred as a program regression. Therefore, after every change to a program, the program must be tested again. It is usually infeasible to have a human perform test, that is after every change to the program. In the same way, we can also expect the changes in the various program that is also expected in the test suite. And the regression testing involves running the programs on each test case in a test suite and checking that the program generates the expected or test output or not. That is the testing applications. And there is a performance testing also, that is to perform the or to test the performance of database, whether the database will be available in the whether the database will meet the requirement of the performance or not. That is, an application meets the performance requirements or not. And to carry out such performance testing, the test database must be of same size as the real database would be. And even if there is an existing database, organization usually do not want to reveal sensitive data to the external organization. They may be carried out the performance test. There are multiple applications, there are multiple testing that is available for the multiple application, like regression testing, beta testing, alpha testing, smoke testing. There are multiple testing. And next is the next issue that is available is the how to migrate the application. So one is the testing, next is how to migrate the application, that is the application migration. So legacy systems are the old generation application programs that are in use by an organization. So whenever the legacy system is used, that is the old one, that is mostly or that is used by most of the organization nowadays also. That is a legacy system, but this is the older generation application program. But that the organization wishes to replace with a different application. For example, many organizations develop application in a house, but may decide to replace them with a commercial product. In some cases, a legacy system may use old technology that is incompatible with the current generation standard in the system. So legacy system may use the old technology that is incompatible with the current generation standard in the system. That is, the incompatible means it is not used with the compatible system, that is not used with the legacy system, that is used with the generation of the computer. Some legacy systems in operation today are several decades old and based on the technology such as the databases that use the network or hierarchical data model, or use COBOL and the file system without a database. So whatever the file system, whatever the database that is available, that is used with the database systems. Such systems may still contain valuable data and may support critical applications. So these are the system that may also contain the valuable data and they may also support the critical applications. Then replacing the legacy applications with new applications is often costly in terms of both the time and the money. And since they are often very large, consisting of millions of the lines of the code developed by terms of their programmer. So whatever the term of their programmer, whatever the team of their programmer that is over uses the line of or millions of the lines of the code. They contain large amount of data that must be ported to the new application, which may be a completely different schema that is that contain or that is used for the large amount of data. Many organizations attempts to avoid replacing legacy system and instead try to interpret them with the newer system. So most of the organization or many organization attempts to avoid the replacing or attempts to avoid the replacing legacy system and instead try to interoperate them with the newer system. That is, try to incorporate with the newer system, try to incorporate whatever the various new system that is available in the legacy system. One approach that is used to interoperate between the relation database and the legacy database is to build a layer that is known as the wrapper on the top of the legacy system. That is an approach that is used to interoperate the wrapper that is used to interoperate on the top of the legacy system that can make the legacy system appear to a relation model. So that is used as a relation model that is used in the legacy system, that is the topmost layer, and the wrapper is also used in the legacy system on the top of the legacy system. So it is like a wrapper, for example a toffee wrapper or anything that is wrapper, a chocolate wrapper that is used as a wrapper for the system. The wrapper may provide support for the ODBC or the other interconnection standards such as the OLE-DB. So wrapper provides the connection, wrapper provides we can say the connectivity or the support for the ODBC. The wrapper is responsible for converting relational queries and the update into queries and update on the legacy system. So whatever the wrapper or whatever the query that is used, the wrapper is responsible for converting the relational queries and the update into the queries. When an organization decides to replace a legacy system with a new system, it may follow a process known as a reverse engineering. So whatever the query that is used, whatever the database that is used to replace the query with the database management system, which consists of going over the code of the legacy system to come up with a schema designs in the required data model. And when a new system has been built and tested, the system must be populated with the data from the legacy system, and all further activities must be carried out on the new system. So whatever the database system, whatever the testing that is used, that is available, that is populated with the data from the legacy systems. However, abruptly transitioning to a new system, which is known as the Big Bang approach, carries several tasks. And since there may be many bugs or the error or performance that is used for the various data that is available in the database management system. Next is the standardizations. So next topic is the standardization that defines the interface of a software system. That is that defines what is the interface, what is the main output, what is the main criteria of the database or software system. That is the standards. For example, a standard defines the syntax and the semantic of the programming interface. That is the rules and regulation that we follow in the programming. That is the syntax and the semantics of the programming languages or the functions in an application program interface. That is a standardization, or that is a standards. Today, database systems are complex and are often made up of multiple independently created parts that need to interact. So nowadays, the database systems that are used, that are more complex and are used in a multiple independent way, that are created as a part or that are used in a part that is used. For example, client program may create or may be created independently of the backend systems. Now, there are two types of, or there are multiple types of standard that is available. One is a formal standard, that are those standard that is defined by the standard organization or by the industry group. That is a formal standard. That means a formal standard is available. We have to follow that formal standard. There is no criteria we have to change the formal standard. No, but we have to follow that standard. That is a formal standard. That is through a public process. Dominant products sometimes becomes de facto standards in that they become generally accepted as a standard without any formal process of the recognition. Some formal transactions or some formal standards, like any aspects of the SQL 92 and the SQL 1999 standards, are anticipatory standards that lead the marketplace. They define the features that vendors then implement in the product. In other cases, the standards or the parts of the standards are reactionary standards. That is a reactionary standard in that they have to they attempt to standardize the feature that the vendor has some time to be implemented. And these are the various names of the standard that is available, like ISO, International Organization for Standardization, or the International Standard Organization, ANSI, American National Standard Code for Information Interchange, ANSI, American National Standard Institute, IEEE, that is Institute of Electrical and Electronics Engineer, then one ASCII, American Standard Code for Information Interchange. So these are the basically we can say the formal standard that is used. Next is the SQL standard that is also used. So SQL is also multiple standard, that is the most widely used query language that is used for standardizing the standards, or that contains multiple standards. ANSI and the ISO with the various database vendors have played an important role in the networks. So NSI, that is American National Standard Institutions, and the ISO, that is the International Standard Organization, that are both used as a database vendor that has played a leading role in this work. The SQL 86 standard was the initial version, and the IBM System Application Architecture, that is the SAA standard for SQL, was released in the 1987. SQL 99 version of the SQL standard added a variety of the features to the SQL, and we may add multiple features in the earlier chapter for the standardization of the SQL. Now these are the various parts of the SQL 2003 that is broken. That is part 1, that is a SQL framework, provides an overview of the standard. Then foundation, that defines the basics of the standard, that is the types, schemas, views, definition, linking, query, update, security model. Then part 3 is CLI, that is a core level interface, that defines the application program interfaces, that is what are the various programs that is available that provides the interface to the SQL. Then PSM, that is a persistent store module, that defines the extension to the SQL that is used in the database management system, that is used in the database management criteria. Then next is the MED, that is a management of external data, that defines the standard that is used in the, or that defines how to interact with the SQL system with the external sources. Then SQL OLB, that is the object language binding, that defines the standard for how to embed the SQL in the Java, how to embed them in the Java. Then schemata, that defines the structure. Then JRT, that is used with the Java routines and the types. Then XML, that defines the XML related queries. Now next is the database connectivity standards, that is also used, that is the ODBC is a widely used standard, or we can say the mostly used standard that is used with the database connectivity, that is the ODBC, that is the Open Database Connectivity. And it is based on the SQL core level interface, that is the CLI standard developed by the X-Open Industry Consortium and the SQL Access Group, but it has multiple extensions that is used. And the ODBC API defines a CLI, that is a sequence syntax definition, and the rules about the permissible sequence of the CLI calls. And ODBC also allows the client to connect simultaneously to multiple sources and to switch among them, but the transactions on each are the very independent, and the ODBC does not support the two-phase commit protocol. A distributed system also provides a more general environment than a client-server system. Then there will be ADO also, that is Active Database Object or the Active Data Object, that is created by the Microsoft, provides an easy to use interface to the OLEDB functionality. Next is the Object Database Standard, that is provided by, or that is provided into the form of the ODMG, that is the Open Database Management Group. Now next is the XML based standard that is used that is also used. These are the various standards. So this is the winding of the chapter. This is a summary. So first is the tuning of the database parameters such as the high level database system design schema. Then the performance benchmark, that also plays an important role in the comparison of the database systems, especially when the system becomes more standard compliant. Then the TPC benchmark is also used. So first is the how to tune the performance, then the performance benchmark. Then we have studied about the application that needs to be tested extensively when they are developed. For example, testing is to find the errors, and the development is used to performance the goal or the goal performance. Then legacy systems are the system that is based on the old generation technology such as the non-relational databases, or even directly on the file system. That is whenever we use the older generation technology such as the non-relational database, or even directly on the file system, that is a legacy system. Interfacing legacy system with new generation systems is more important when they run mission critical systems. Next we also talked about the standards that are very important because of the complexity of the database system and their need for the interoperation. Formal standards exist for the SQL, and the de facto standard that is also available like the ODBC and the JDBC, and the standard adopted by the industry groups such as the CORBA has also played an important role in the growth of the client server database systems. And these are the review terms that is used. Then these are the practice questions that is used in this one. And this is another question, that is how to develop a database application that the desktop is used, and what are the various criteria that is used for this one. These are the another exercises. These are the bibliographic notes. Then the next chapter is chapter number 25, that is a spatial and temporal data and the mobility, that is how to use the data, spatial and temporal data. So that's all for today's session. This topic, this chapter, I'm going to start in the next session, in the next class, that is in the tomorrow's class. So that's all for today's session. Thank you so much everyone for listening me. In the tomorrow's class, I'm taking the next chapter, that is chapter number 25, that is the spatial and the temporal data and the mobility. That's all for today's session. Thank you so much everyone. Bye bye. And if there is any doubt, you can ask the doubts from me.